Okay. Here we go. Pop out chat. Okay. Let's put that down there. Okay. Welcome, first member. Feel free to introduce yourself when you enter the chat, so I know who you are. Alrighty. Sure, Aubrey. Let's go over that now before people start showing up. Okay. Do you have any questions in particular that you wanted to go over to make sure you have them correct? A flowchart style. Okay. Sure. Yeah, I can do that. Why not? Let's see what I can do here. Okay. So let me see. We learned about 3 processes, right? So you have DNA replication. That's the first one. In DNA replication, you start with one strand of DNA, and the process creates 2 strands of DNA. So let's go down here. DNA replication. You start with a single strand of DNA. And through replication, you end up with 2 strands of identical DNA. Right? Okay, so there's DNA replication. Then we did transcription. And in transcription, we started with don't do that. We started with DNA strand in transcription. And after transcription is done, that DNA strand got copied into that strand got copied into strand of mRNA. Okay. This mRNA strand, if we wanted to build off of that, is used in the next step, which is translation. Right? Translation. And in translation, you start with the mRNA strand. Okay. Nope, don't do that. Whoops. There we go. Started with the strand of mRNA, and a ribosome reads that strand of mRNA, and from that code transforms that strand of mRNA or reads it and creates a corresponding strand of amino acids, which turns into a protein. Correct. Yeah. So replication, here, let me help you out with this a little bit. Yeah, so replication is kind of its own thing. This is independent of these 2 steps over here, right? So this is for making more DNA, and these 2 steps are joined in order to make proteins that are coded for in the DNA. All right, does that help? All right. Cool. We still have another 10 minutes or so before people, before I said we would begin. So I guess if we want to just start asking questions, you're welcome to do that while we wait. But I'll leave it up to you, right? If there were questions on the study guide specifically that you guys weren't sure on, I have the study guide up here, and I'd be happy to go through different questions and you know, help you make heads or tails of that if you're not sure. Mm-hmm. Okay, first question. Again, guys, this screencast or this live stream is going to be recorded, and I can post it to the Google Classroom. So if you miss anything, you can find this video there. You can fast forward or rewind, and you know, check it out. Take your time with it. So, good question. Do you need to know the difference between eukaryote and prokaryote and how they copy their DNA? No, you certainly do not. We took out any questions that had to do with prokaryotes and DNA replication. So no, you do not have to know anything about that. You just have to know the general process of DNA replication in your cells, which is what we've been talking about these past few weeks. So don't worry about that. The definition of a codon, Soleil, is this. If I have a strand of DNA, right, let's say this is half of a strand and the other strand is not here, it's somewhere else. A codon is every 3 bases in a DNA or an mRNA strand. So let's say I have T, A, C. Every 3 bases is a codon. So what you're seeing here, that's our first codon, right? So a codon is any 3 bases. Yep. Page 2, number 7, labeling diagram specifically the processes and structures. Okay, Ethan, before I do that, Soleil, do you understand what a codon is? Soleil, yeah. An anticodon, the anticodon is only found on the tRNA molecule. So a tRNA molecule, we'll get to your question in a moment, Ethan. A tRNA molecule looks like this roughly, right? You've got your T shape, and then you've got your amino acid here that's on the top like that, right? So there's our amino acid attached to our tRNA molecule. This would be an anticodon, right? Now, I'm not going to ask you specifically what that is on the test, but this is it generally speaking. So if I have the anticodon, let's say this is C, C, G, we'll say. These are the 3 bases in this anticodon. If I have a strand of mRNA down here, here's the codon on the mRNA strand. What should these 3 bases be if the anticodon on the tRNA molecule is CCG? What should these ones be? CCG will stick to what? GGC, correct. So this codon would be GGC, and that would stick to this tRNA anticodon, right? So the codon can only fit the right anticodon. That's how the ribosome gets it right every time, right? Otherwise, you'd get a mismatched protein every time. But the ribosome can only stick the right tRNA molecules to the codon of the mRNA molecule. Now here's a question for all of you guys. Since we all know what a codon is now, it's every 3 bases, how many codons do you see in this DNA strand? I want everybody to answer. That means you, Ryan Whitley, Ethan Putnam. How many codons do you see in this DNA strand? No, not the bases. How many codons, silly pants? Good. 1, 2, 3, 4, 5, 6. Correct. Good job. 1 codon. There's 1. There's 2. There's 3. There's 4. There's 5. And there's 6. All right. Good job. Nice. Look at all you smarty pants. Wow, this is weird. Okay. Let's get rid of that. Now, Ethan, you had the question. Let's go to the study guide. Here we go. Your question is, can we go over question number 2, or page number 2, number 7? You're talking about this thing right here, this diagram? Is that what you is talking about? Yes, sir. Okay, cool. So general description, that's just asking you to put what is this process we're seeing here. What do you guys think? What does this picture show us? What does it look like? What do we have? What are we making? If you had to guess, what's going on? Undo text box. That will help us. Yep, I see DNA. You are right, Ryan. I see DNA. But what is this DNA doing? Oh no, don't want to do that. Whoops. Edit, undo. Edit, undo, undo. Mistake. Danger. Let me see if I can't wrap this real quick. That would be under elements. Wrap text. How do I wrap text? Where's the wrap text layout? Maybe it's under layout. Maybe not. Where's the wrap text? Hold on, guys. Just a second here. Well, I'll just write it with my little thingy. It's not transcription. Nope. Transcription is when you create mRNA, right? Yep, so those are all things. Polymerase, that is a thing. But what process? Of the three processes we've learned, DNA replication, transcription, and translation, which one do you think this is? Right, this is replication, and I'll show you why. Good job, Ryan. Yep, you're right. Both Ryans. Ryan squared, you're right. So here's how you can tell. If you look up here, I have one DNA strand, right? There's the beginning, our single DNA, but you can see it's opened up here. This is our fork, right? Right there, and it forks in half, and you can see how now we have this one turns into one and turns into two, right? So we see two DNA strands coming from one. That tells you this is replication. To replicate means to copy. We are copying our single strand, making two more new strands, right? Okay. DNA replication. Matt Almeida, good to see you, buddy. Okay. So if we had to write a copy here, we could just, or write something down, we could just say DNA is being copied, or DNA copying, right? That's easy. DNA copying. Okay. What process? You guys just told me this is DNA replication, right? Okay, so we can fill that out. DNA replication. Replication. That's a mess. Okay. So this is asking you about the process, right? DNA replication. You can see here this is being split. So we need to write some stuff down. Yeah, you're right, unknown, whoever that is. Writing with the mouse is totally whack. I am not comfortable with it, but we do what we can. So DNA replication, we'll say that's what this is. Replication. I hate writing with the mouse. There, good enough. Okay, process. What do we see happening here? What do you guys notice is going on right there? What would you say? Ryan, there are a couple pictures that you have to label. So just be able to identify one step from another, right? If you see a picture where you start with one DNA strand and you end with two, you know what that is, right? Good. It's being opened. They're breaking apart. Helicase. You're right. All of you are correct. So number one is pointing to that. So we can say, because it says use these words, DNA helicase, we can say helicase. We can't see the helicase. It's probably come and gone already, but you know it's been unzipped, and we know helicase does that. So helicase unzips. I hate writing with the mouse. Unzips DNA. There we go. Okay, so that's step number one. Step number two, what do you think is going on? Step number two, what process, what thing is happening here? It looks like I see bases that are floating around, and they're being added to the half a strand that's left over here. Yeah, I tried Soleil to make a text box, but when I do that, it pushes this whole thing to the side because I can't remember how to wrap text. If I could figure out how to do that, it wouldn't be a problem, but we'll make do. Yes, I can type in a text box. Yes, I can, but it just makes the picture wonky, so just deal with it. Yeah, free-floating nucleotides attach. Who does that? What enzyme? What is this shady enzyme here called that's attaching those free-floating nucleotides? Who's doing that? Good, the plotmerase, the polymerase. Yes, so this is DNA polymerase. DNA polymerase. We're just going to abbreviate it with poly, right? DNA polymerase, just so you know what that is, polymerase, makes new strand. That's what it's doing. It's attaching those bases and it's making a new strand. Makes new strand. Okay, so you can see the DNA polymerase is making the new strand with these loose bases here and here. Those are going to get attached. Number 3, if I had to guess, it looks like this new strand is being glued together here. So what would you say this third step is happening right here? DNA poly and RNA poly are different. You are correct. DNA polymerase copies DNA. RNA polymerase, excuse me, I just ate pizza. RNA polymerase takes the DNA and copies it into mRNA, hence why RNA polymerase is called RNA polymerase, right? It's a day 4 tomorrow, Ryan. I believe you are period 3, so you actually have your test last in the day. Yeah, so Soleil, good job. Unknown, Soleil, you both said ligase. So we can say ligase. Ethan, what does getting chirped mean? I have not heard that before. Before you get chirped, I'm interested. What does that mean? Okay. So the ligase is gluing this together. You can see this other half is getting glued to the first half, right? Okay. The end result, what do we end up with? When this is all done, exposed. Oh, okay. Good to know. This one strand is being split and copied. What are we going to end up with? What do you guys think? When DNA replication is over, what do we get? A copy. New strands of DNA. Just one strand? So I can just get one copy? Just one DNA? 2 DNA. Yeah, okay. So I get 2 strands of DNA. Good. There we go. Told me you're in section 5. Okay, so you're probably one of the bros in section 5. I know who you are. I know you. Okay. Identify the structures. This is actually pointing to the physical things. This is asking you what's happening, and these numbers are pointing to what is each of the things it's pointing to, right? You guys try this live stream is so we can learn. Stop joking around. Ryan Whitley, where is this when I need you in class? Come on. All right. Identify the structures. What is being pointed to here? What is this thing? Number 1. Generally speaking, this whole thing right here. Help me out. Come on. It's a helix, but what is the helix? What is this actually called? The shape is a helix. The DNA. Yes, it's the DNA. Good job. DNA. That's what this is pointing to. Good. Number 2, it's pointing to this little guy that's floating out here, and it's pointing to these little guys that are making up this stuff here. Number 2, what is number 2 pointing to, guys? Come on, help me out. Real quick, you got this. You're wicked smart. Bases. Good job. Okay, these are the nucleotides, of which bases are a part of. Nucleotides. That's these guys. Okay, number 3, almost there. Number 3 is pointing to this dark, shady thing that looks like it's copying and adding new bases. What did we say that is again? This dark, shady thing. Soleil, if you look, these are nucleotides here. Yes, there is a base. These white, bars are the bases, but it's also got the dark part. That's the sugar and the phosphate. The whole thing is a nucleotide. Number 2 is pointing to nucleotides that make up the DNA strand. The monomer of nucleic acids. Well done, unknown. So what is this thing? Come on, once again, this shady guy right here, building the DNA strand. Who do we say that is? You can do it. Good, it's polymerase. You're right. That is polymerase. It is... Oh, nope, sorry, that goes up here. It is polymerase. Well done. And number 4 is pointing to this dark strand. What is that? Look, guys, I made a shark. Awesome, huh? Nope, it's not RNA. Look, we have these 2 white parts of the helix, and then, oh, the white parts unzip, and we're building a dark part. What would you say that is? The question is, so I have these 2 white ribbons. Do you see them? These are each side of the DNA molecule. That splits. We've got 1 white side over here, 1 white side over here. It's asking you, what is the dark side? This dark side strand over here. Don't say Anakin or Darth Vader. I'll be very upset. The copied strand. Yes, you are correct. This is the new. Number 4 is the new DNA strand. That's the new side of the DNA. Good job. The dark side. Okay, cool. We good, Ethan? All good? Yeah? Maybe? Perhaps? Yes, sir. Okay, good stuff. Once again, don't feel like, if you didn't write this down, not a big deal. I will be posting this video to the classroom. You can find all the answers there. It takes place where? Good question. Where does DNA live at all times? Always. Unless the cell is splitting. Where would you look for DNA? In the nucleus, correct. So where does DNA replication happen? It happens in the nucleus. Good. So I'll draw a nucleic acid, or sorry, a nucleotide off to the side here for you, Soleil, so that you can see it. Right? Okay. So a nucleotide, Soleil, has a phosphate. Is that my cat in the background? Oh, it is. Hey, cat. Yeah, Hearthstone is sneaky down there in the bar. All right, you've got a phosphate, you've got a sugar, and you've got a base, a nitrogen. We're just going to abbreviate N, right? N base. This whole thing is a nucleotide, right? And if you look up here, Soleil, you see examples of them right here. So I can actually just point them out here, right? So this is a base, A, nitrogen base adenine. This is a sugar, deoxyribose. And this is a phosphate, right there. Combined, they make a nucleotide, right? Sugar, phosphate, base. The sides of DNA are made up of repeating phosphate, sugar, phosphate, sugar, phosphate, sugar, phosphate, sugar. And the middle, the rungs of the ladder, are attached by the bases, right? Okay. Next question. Oh, quick extra credit question. You ready for this, guys? Whoever gets this first, I will give a 1/4 of a point of extra credit. What do these dotted lines represent? Real quick. Who's first? Who's going to get that extra credit? Those dotted lines, what are they? Come on, help me out. Here we go. Okay, Soleil, well done. Hydrogen bonds. Yep, they are. Those are hydrogen bonds. Oh, Aubrey. Oh, so close. So close. Hydrogen bonds. Yep, they're all hydrogen bonds. So, oh, you have a delay unknown? I'm sorry. Maybe if I knew who you were, I'd care. Oh, snap. Okay. Why do we use hydrogen bonds? Why do we use hydrogen bonds to hold DNA together? I thought DNA was super important. Why do I use these weak hydrogen bonds to hold this important molecule together? What do you guys think? Weak force? Yeah, they're weak. So what? Why do I use them? Why not use covalent bonds? They're nice and strong. I like DNA. I don't want it to break. They are the weakest bonds. Yeah, Tommy Cox. Out of left field, Tommy Cox, because they need to split apart when you replicate. Man, Tom, you must be listening in class. Good job. Okay. Yes. All right. There you all are. Ah, look at that. You all knew it. Okay. Good job. Next. Oops, sorry. What else? What other questions do we have? What other questions? I'll wait on you guys. I'm not going to just go through the study guide. You got to have specific ones. Function of each RNA. Yes, we can do that. Sure. That's a good one. Okay. Did replication, RNA and DNA. Okay. Here we go. Functions of RNA. So we have 3 types of RNA. These guys should be pretty easily distinguishable. Do number 5 on this page. Okay, Ryan, I'll go back up to that after we do this. So we have 3 types of RNA. We've got this little strand here, which gets made in transcription. We have this guy, which looks weirdly like a letter of the alphabet. And we have this guy, which is a big lumpy mass. Ryan, I don't always skip you. Come on. Okay. So first off, we can do this one because it's got a very distinctive shape. You guys should all know what this is. Letter B, what type of RNA are we seeing here? What is this? tRNA. Good job, Ryan. See? tRNA is B. You're right, because it looks like a T, right? Silly pants. tRNA. Transfer RNA, right? So to transfer means to move something from one place to another. So what is the function of T transfer RNA? What is it transferring? Remember our sous chef moving ingredients to the head chef. What does tRNA transfer? I'll give you a hint. It's this thing right up here. What is that thing? What are the ingredients? Ooh, no, it doesn't transfer codons. The codons, the anticodon, you mean, because this is an anticodon, 1, 2, 3, has to match the codon of this guy, but it's not transferring a codon or anticodon. It's transferring this, the amino acids. Good job. Unknown. Unknown, I wish I knew who you were so I could praise you for being so awesome. tRNA delivers, transfers amino acids, delivers amino acids. All right, amino acids. Okay. Next, okay, so this guy we got. How about letter C? That looks pretty distinguishable. We know tRNA, so what type do we think this guy is? It's a single strand. I'm not going to try, no, I don't care that much. Just tell me who you are. I'm not going to play a guessing game. That's the mRNA, Ryan Burba. Burba for the win. So Burba, mRNA. What does that M stand for, Burbs? Come on, Burb. What is this thing? What does mRNA do? And yeah, what does it do? How does the M in mRNA describe what it does? Let's go messenger. Nice job, Burbs. Okay, yes, you're right. mRNA is the messenger RNA, correct. And that means it is a messenger. It is delivering the gene message. I always almost get message and massage confused. It's not a gene massage. It sounds nice. It's a gene message. Okay. Delivering gene message, and who is it delivering it to? I'll tell you, yes. Soleil, I'll tell you where each one is found in a moment. Correct. Unknown. Whoever you are correct. This stuff is found in the nucleus. Well, it's made in the nucleus, but it travels to a ribosome in the cytoplasm, right? So it starts in the nucleus, but the whole point of messenger RNA is that it delivers the message that was made in the nucleus out to the ribosome. Good job, right? Delivering gene message to ribosome. Okay, ribosome. There we go. Okay, and then we're left with just one other kind. We've got tRNA, we've got mRNA, so that means this guy must be what? This guy right here. Sophia, hello. Well, this is a ribosome, but that's not the type of RNA it is. We have to use the words RNA. Yes, it's the rRNA, cytoplasm for tRNA. There we go. And you are correct, y'all. This is the rRNA, also known as ribosomal RNA. That's where the R comes from, ribosome, because that's what ribosomes are made of, rRNA. rRNA, what does this ribosome do? It does make up the ribosome. What does it do, this rRNA? How many of you are actually in here right now? It feels like there's way more of you right now than there... Whoa, 18! Holy crap, there's twice as many of you now as there were earlier in the day. Cool. It's good to know. It makes the proteins. Yes, everybody, correct. It makes proteins. It does. It makes proteins in the process called... Makes proteins. What is the process where you're actually making proteins? You guys remember when you're reading this and turning it into proteins? What's that step called? I know you can do it. I believe in you, children. What is it? You got Willie to join? Nice. Translation, correct. That is translation. Nice job, guys. That is translation. Yes, yes it is. Okay, good job. Nice. All right, so we've got our 3 types of RNA. So, what else? Somebody here had another question, didn't you? Somebody asked something. Burba's trash at COD went 6 and 16. Burba, come on, man, that's not even funny. I don't see the other question. All right. Fortnite after this. I've heard about Fortnite. Anyways, enough about games. What other questions did you guys have? Where does it happen? Well, we've kind of described that here, right? So this stuff, mRNA, is in the nucleus, goes to a ribosome. Ribosomes and tRNA are both found in the cytoplasm, right? So these guys are both found in the cytoplasm. The central dogma of molecular biology. And Ryan said number 5. Ryan, I won't skip you. I won't skip you. Okay. But where does the tRNA go? Okay. Aubrey, I will show you. Ryan, let's do number 5, and then Aubrey, we'll do you after that. We'll do your question after that. So let's go up to number 5. Sure, number 5. Why not? What are the 3 roles of DNA for the cell? Well, that's a good question. I know you guys can probably tell me one. What is the purpose of DNA? What does it do? Or what are some of its functions? Okay, good, yeah. So its job is to copy or to replicate, right? To copy / replicate. That's one role. Good job, Brian. That is one. It has the so genetic storage, Mr. Burba, yes, it stores genetic info. It sure does. Stores genes. You have 25,000 different genes approximately. It stores all of those. It stores them and it expresses them. Yes, it does. It does express genes. It stores and expresses genes. Expresses genes. Good. Yeah. Mutation and recombination. Those two words are discussing something we're going to talk about beginning of next unit. To express, that's a good question, Soleil. So here's what we mean when we say to express a gene. So let's say that we're looking at an Arctic hare. Some of you, I talked about this. Turn on post notifications and like the stream. I don't know what you mean there. So let's say we're looking at the Arctic hare, and I know one of your classes I talked about the Arctic hare with as far as genetics go. So in the winter, the Arctic hare is what color to blend in with the snow? What color is the Arctic hare in winter when it's snowy? It's white. Good job, Lily. It's white because the gene for white hair is being expressed. It means that it's being transcribed and translated, right? That means to express a gene. If you're transcribing and translating a gene, it means you're making that protein, which means that that gene is being expressed, right? When I say, Soleil, don't sit there and be all quiet, express yourself. It means that you're going to, be outspoken. You're going to show up and kind of be there. So gene expression relates to the idea that genes, when they get turned on, you see them expressed in the organism. So the white-haired gene in the rabbit is expressed in the winter, and you see that in the color of the rabbit, right? Yes, Ryan. White is all the colors. Yep. Too bad you didn't talk about this in our class. Unknown, I'm getting tired of your sass. I'm just going to boot you right out of this if you're not careful. Okay. So what are the 3 roles of DNA? There you have it. All right. Let's get rid of that. So now, Aubrey, you had a question. And Aubrey, what was your question again? Can't quite remember. Let's see if I can see it up here. So I got the mRNA. Where does the tRNA go? Sure. Let's draw it here. I think it's so funny that you guys, Ryan, Willie, all y'all, even distract each other in a chat. Right? It's not just in the class. You're even distracting each other in a chat. Can't even see each other. All right, so central dogma. DNA is the dogma. DNA is not the central dogma. No, that's not correct. So here, no, I do not get ad revenue. No, I wish I did. That'd be cool. The central dogma of biology, I can actually do both those things, tRNA, mRNA, and rRNA, and cover the central dogma. So we'll do that right now. So I did this with some of you the first session. Some of you are showing up for double session. Kudos to you. But if you remember, if we're looking at a big old cell here, inside of this cell is a nucleus, right? There's our nucleus. This is our cell. The central dogma of biology, that means the founding principle of biology, is that your DNA codes for your proteins. Silly pants, right? DNA gets transcribed into mRNA. Say this is mRNA. mRNA. And then that gets sent to a ribosome. Right, we'll just make a ribosome right there. The ribosome gets the instructions from the mRNA. And it turns those instructions into some squiggly lines, some more squiggly lines, and some more squiggly lines. And when they all combine, you call this a protein. So the central dogma of biology is this. It's that your DNA, through the process of transcription, that's this arrow here, making your mRNA and having it leave, DNA through the process of transcription and then translation codes and makes your proteins. That's it. Do you get N1? We get distracted, but we listened to you when you told us to join. You did, Ryan. I appreciate that. Okay. And I'm glad, Ryan, that you find this helpful. That's why I'm doing it. I'm going to try to do this before every test, I think. I think it might be helpful. So this right here is the central dogma of biology. Your DNA codes for your proteins. Number 13, yes. Tommy, I think I will start doing this more. Okay. Does this make sense? This here is the central dogma, Aubrey. Yes, I'm seeing a few people ask about 13, so sure, let's do that right now. Okay, here we go, number 13. Let's check it out here. Number 13, which one's that? Number 13. Oh, yeah, look at that hot mess. Yep. Okay, yeah, there's a lot going on there, huh? But we can figure it out. Central dogma, we did that. Describe the process of transcription. Yeah, okay, we've done that. Let's take a look at this guy. Okay. So number 13 is just basically saying, okay, what is going on here? What are we looking at? We see RNA polymerase. I'm giving you some clues. We see RNA polymerase. We see this strand that's, oh look, it's been unzipped. And RNA polymerase is making something here. Yeah, I'll go over those in a second, Allie. Your 13 is different. Your 13 isn't this question? Oh. Is it this one? Maybe I have an old version of the study guide here. Is this the question 13 for you guys? Okay. It's not this one. Oh, it is this one. Oh, it is this one. It's this one. Okay, this one. What did Willie ask? Where is Willie? Oh, Willie asked how long the test. The test is designed to take the 49 minutes that your period will be tomorrow. So since it's a super advisory tomorrow, periods are only 49 minutes long. That's how long the test is designed to take. Okay? Okay, sure, yeah. So, hey, all right. This is interesting. There's a lot going on. But we can do that. So, where does translation take place? Label the following diagram. Here we go. Translation. So it tells you we're looking at translation. Translation uses a chef, that's this kind of big blocky guy here, in order to make something from a code that was made in transcription. So you're not going to fail. I hate it when you guys say that. You're not going to fail. Nobody fails. You guys know how rare it is that somebody actually fails these tests? Okay. Anyways, back on task. Number 3 is pointing to our chef here in translation. So let's take a look. What is this chef showing us? Who can guess? What is he? It's translation. The chef in translation. Well, Conti, I'm glad. Welcome. Who's the chef? Come on, guys. Ribosome. Yes, it is. C-Soleil. Come on. You're always saying you're going to fail, but you know all the answers. Silly pants. Come on. All right. Number 3. This is a ribosome. This is our chef. He is the one that reads the instructions made in transcription and turns them into something else, right? Okay. So number 3 is a ribosome. So we know this is a ribosome. That means we can start filling out some other stuff. It looks like number 4 is pointing to this whole thing right here. And let me give you a hint. Are you ready? If I were to draw this the way you remember it from class, it would look actually like this. So what is number 4? Good job. Do you guys see it? This is, yes, good job. This is the tRNA, okay? tRNA. If I didn't show you this, you would know it's the tRNA because you see these guys right here, right? 1, 2, 3. And you also see this thing right here. Those are the clues that you could have used if I hadn't drawn that T. So we know that every 3 bases here, right? 1, 2, 3, boom, boom, boom. Every 3 bases is called a what? There will be pictures on the test, Tom. Yeah, there will be pictures on the test. The pictures might be transcription. The pictures might be translation. The pictures might be replication. I can't tell you which one specifically is going to be on there, but I can tell you that one of those three will. Okay, Soleil, Sophia, you are correct. Number 5 is pointing to one of these three pairs. That is a codon. That's okay, Ryan. If you don't know what to ask, that's fine. Just listen along to what other people are asking, and I'm sure you're going to learn stuff as I answer other people's questions. It's okay. You don't have to have a question. Just try to focus while we're doing this, and you'll be fine. Don't worry, guys. I also wish that most or more of you would come up and talk to me during the test. You need to know I don't frown upon you guys coming up and asking for clarifying questions. I'll help you. I will do the best I can during the test. If you come up and you say, Mr. Hearn, I'm not really getting this, I will drop you hints. I like doing that. So please take advantage. Come up. Don't ask me what the answer is because I won't tell you that, but I will guide you. Okay? So please start doing that. It will help you, and I don't mind doing it. Okay? All right. So if every 3 bases on this strand here is a codon, that means that these 3, what are these guys here? They're not a codon, but they're close. I know, Ryan, and I know, I appreciate that. I see you come up all the time, and I'm so thankful that you do. That's a good habit to be in. Yeah, good job, Aubrey. This is the anticodon, right? Okay, anticodon. Boop. Okay, that's the anticodon. Okay, so our tRNA has an anticodon that will match the codon on this guy. So number 7 is pointing to this strand that was made in transcription. What is this strand here? The anticodon of the tRNA matches the codon of the what's this thing here? I'll give you a hint. It was MMA. I don't think it's MMA, mRNA. That's right. Yeah, mRNA. Good job. What does MMA stand for? Is that cage fighting? MMA? Yeah, I think so. Something like that. mRNA. So this is our mRNA strand. Number 6 is pointing to the bottom part of this ribosome. You don't need to know number 6. It's a very specific term. You just need to know that number 6 and number 3, like a ribosome sandwich, they both make up the ribosome. Okay? Okay, good. Now we just have numbers 1. Well, we just have really number 1 left. Number 2 is pointing to a very specific bond here that you guys didn't learn about. It's called a peptide bond. Remember, this is a polypeptide, and the peptides are held together by peptide bonds. You didn't learn that. You don't need to know that, but I'll write it down anyways. It looks like the peptide bond number 2 is holding together these objects that make up number 1. So these guys are the ingredients. Remember, the tRNA is bringing the ingredients. So what are the ingredients? The monomers of the protein that's going to be made here. It's not a hydrogen bond. It's called a peptide bond. That's this. But the peptide bond is holding these 2 guys together. And what are these 2 guys? Good job, Aubrey. Thank you, Aubrey. Somebody's listening. Amino acids, correct, Sophia. Good job. These are the amino acids. Remember, MET is always our first amino acid, right? The AUG codon. That sounds familiar. Amino acids. Okay, good. You mean this number 2, Soleil? Is that what you're asking me? There are 20 different types of amino acids, right? You can combine them in any way to make up a protein. AUG is the first codon. You're right, Aubrey. So MET, this guy must have been MET. That means that this codon would have had to have been AUG right there. That would have been our MET because he dropped off the MET first, right? So that was 1. This is 2, and this will be 3 that will attach there afterwards. Okay? So they move in this direction. You can see the arrows. The ribosome moves down, chunk, chunk, chunk. Okay, so we'll go over dogma. All right? All right, the central dogma of biology. Sure, because why not? Remember, the central dogma of biology, of molecular biology, I showed you that picture earlier. I drew a cell and I had the nucleus and the DNA. DNA, through a process, gets turned into a strand of what, and then in the next process, finally gets turned into what? Who can fill in those blanks? What's number 2? The first process. DNA in this first process gets turned into this single-stranded thing. What is this first process? The sous chef in the secret room copying that big cookbook. What is that process? Transcription. Good job. So this first process is not RNA yet. RNA is a thing, not a process. Transcription. That would be like saying, you know, how do I make a meal? That would be like answering pickles instead of cooking, right? So transcription is cooking, that's a process. Pickles are an ingredient, so transcription. DNA, through the process of transcription, makes a single strand of what? What should we put here? What's this one? Good. mRNA, right? mRNA. mRNA next will leave and find a ribosome, and in the process of blank, what's that process? The next one also starts with a T. Good job. Translation. Through the process of translation, makes what? Translation takes mRNA and combines a bunch of amino acids to make a finished meal, in this case proteins. Yes, the proteins. Good job. Nice. You all know that. Yes, Ryan, you can do that. That would be fine. Okay, so the central dogma of biology is that your genes, your DNA, code for your proteins. And you do all this junk here in the middle to get from A to Z, right? This time I'm Willie and you don't get any of these. Well, Ryan, I'm not sure what else I can do, buddy. I wish I could just kind of take what I know and jam it into your head, but, you know, technology doesn't exist, so the best I can do is review it with you right now. Do question 12. Do it. Do it. You won't. Do you even lift, bro? Okay. Conduct DNA replication. That's your. This is great. Live. Ethan, be supportive, man. Come on. I'll do 15. Use the table below to differentiate between DNA replication, transcription, and translation. DNA replication. Conduct does mean to do. You are right, unknown. Conduct means to do, or to, yeah, facilitate, you might say. Yes, you did. Where does DNA replication happen? Hey, Ryan, I don't want to see that. If you guys start, you know, saying dumb crap to each other in my chat, I'm just going to start kicking you out. So focus on this, not on your peers. Your 15 is my 16. So you want to do this one. Be able to conduct DNA replication transcription if given a DNA. Ah, yes. Okay. Yep. Yep. Okay, we can do that. Number 16. You ready, guys? I'm going to give you all a bit of practice. Here we go. This is going to be good. Oh, boy. Thank you. Okay, so here's your practice. You ready? I'm going to give you a strand of DNA, codon by codon. And then let's do, how about just stop? We'll just do 5. Okay, so this is your strand of DNA. That's what we start with. DNA. Now, we're going to underline it so it looks like a strand. So that's our strand of DNA. I want you guys to take that strand of DNA and transcribe it into a strand of mRNA. Okay, so let's not underline this anymore. 9.5 out of 10 stream. Well, you know, Ryan Burba and Ethan and other Ryans, if you like what you're seeing, you can always hit the like button and subscribe to my channel. Here we go, 100 subscribers. All right, so Lily says AUG. Yes, TAC in transcription goes to AUG. That's always first if you guys remember, AUG. AUG followed by, what's the GGC turn into? CCG. Lily is correct, CCG. AAT, good job Lily, turns into UUA. CAC turns into GUG. And stop. Okay, good, right? Now we need to do translation. So for those of you who are all like, wait, no, I don't, what's happening? I'm so lost, I hate this. I'm going to show you really quickly. No, not with that. Go away. Go away. Go in. Nope, go away. I'm going to show you really quickly how we got to this point. Okay, so now we're going to make a protein. So are you guys ready? Here we go. Our familiar friend. Wait for it. There we are. Oh, we remember him, right? Oh, look who showed up. We can use this tool. Okay, look at Tommy already on it. Man, Tommy, you're bringing the heat today. Here we go. So AUG, if we plug that in, follow along with me, guys. You ready? Remember, you start in the middle, A, you work your way outwards, so A to U to G gives us MET. It's a little blurry, but that says MET. M-E-T, right? Okay, after MET, CCG. CCG. Oh, Tommy, you said leucine. Tommy, I'm not sure that's correct, Tommy. Oh, Tommy, oh no. CCG is what? What would CCG be? Proline, correct. C, work your way out. C, work your way out. G, proline, P-R-O. Okay. Next, UUA, starting with U and working our way out. Good job. Yep. Hannah, Ryan, correct. It's okay, Tommy. The best of us make mistakes, right? Failure is how we learn. UUA, what would that be? Leucine, correct, Sophia. Well done. I expect more, Tommy. Ryan, that's cute. Okay, G-U-G. It's okay, just tell me the first letter, and that's fine. G-U-G. What would that one be? Valine, correct, Sophia. Sophia, you're on fire. You get this stuff. That's good. Okay. And there is our polypeptide chain. Let's make that one a nice mossy green. Nope, that's not it. Nope, that's red. Nice mossy green, right? Okay. So transcription, you start with DNA. In transcription, you turn it into mRNA. In translation, the ribosome reads the mRNA and puts together your protein using this amino acid wheel, right? So this was the answer to number 15. When I say make sure you can conduct protein synthesis, or sorry, DNA replication, transcription, and translation, that's what I mean. I might give you something like this. Hint, hint, nudge, nudge. I might give you something like this, and I might ask you to do what we just did, okay? Make sure you can do that. I feel like all of you have proven to me that you are somewhat comfortable with this, okay? So, right, how are we feeling about this? Is this okay? We're feeling good? You guys could use that wheel and make something like that? If I give you this, can you, if I start you off with DNA and provide you with this wheel, could you do this? Ryan says you and Willie are good. Good. Ryan and Willie say they're good. Well, then we're ready to move on, right? Okay. Just so you know, this is the cockpit of the Space Shuttle Exploration, I think. No, not Exploration. Whatever that one is, but yeah. Okay. You guys were asking me about question 18. What are mutations? Yeah, what are mutations? We really didn't get a chance to talk about that, did we? Well, you tell me. What are mutations? You guys know. We've talked about it several times. Oh. What are mutations? $19. Look at that. I'm super famous. That's awesome. I'm going to have to start streaming my Overwatch games with 19 followers. When it's not how it's supposed to be. What do you mean, life, Hannah? Are you talking about life when it's not like it's supposed to be? I know that feeling. I'll check it out, Ryan. Only if you tell me what mutations are. Mutations. Help me out here, guys. We talked about them. When what's not supposed to, when what is not how it's supposed to be. I've heard a lot about PUBG. I have, and I'm very interested in it, Ethan. I'm seriously considering picking it up because it sounds ludicrously fun. Hannah says when the letter is copied wrong, leading to an incorrect protein. Changes in the DNA. Changing of a gene. Yes, there it is. Good job. Mistakes. Base is correct. Okay. So what are mutations? They are changes in the DNA code that aren't supposed to be there. So we're going to talk about those really quickly. If you guys would, you and Willie both said that. Great. Okay. So changes. So I'm going to show you guys something really quickly concerning. We're going to go back to this actually, and you're going to see how mutations can affect something. So this is our original strand of DNA, right? Remember, we started with this. So let's pretend that DNA polymerase, when it's copying the DNA strand, you know, it shows up, it's a little worse for wear that morning, it's not really feeling it, and it goofs, and it makes a mistake. And the mistake it makes is this. Ready? It takes this GGC, and oops, instead of a C, it makes another G, so we got triple Gs now. Whoops. Okay. I'll keep going, Aubrey. As long as people have questions, I'll keep going. No big deal. If I change that third C to a G, what is that going to do to my mRNA strand? So for reference, this right here was our mutation. This G used to be a C. So if I change that C to a G, what do I need to do to my mRNA strand now? Xbox. Soleil, you're getting way ahead of everybody else. I know you were here for the first session, and so this is still fresh in your mind, but I'm not asking you what the end result is. I'm asking you what the result on the next step is. So if we change the DNA, what happens to our mRNA? What do I need to do to my mRNA strand now? Does the DNA strand match the mRNA? Okay, what's wrong with the copy, the mRNA copy? What's wrong with it? What do I need to change? Help me out here. You tell me. I'm asking you to proofread, Aubrey. Tell me. Proofread it. What's wrong? Which one? You should pose it like this. Mr. Ahern, you need to change the blank to a blank. In this mRNA strand, something doesn't match now. Yes, there you go, Ethan. Thank you. Yes, I need to change this G to a C. You're right. Okay, Ethan, good job. I did. Look. So because of the mutation in the DNA, the message that I copied is also changed. What is that going to do to our second amino acid? This orange G is my mutation right here. Yep. You're right, Ryan. A little late to the game, but you got there. Okay. This third G is my mutation. Because this turned to a G, I had to turn this mRNA codon into a C. Ah, Rick and Morty. Yes, Rick and Morty says nothing. Let's take a look if he's right. It used to be CCG. CCG gives us proline. We changed it because of this mutation to CCC. Hey, look at that, guys. Do you see that? It didn't do anything. This mutation didn't have an effect on our protein. This is very common, right? Most mutations like this don't change anything. We call them silent mutations because they're silent. Even if they happen, you don't see it because it doesn't matter. I could do CCG, I could do CCA, I could do CCU, and I would still get proline. A mutation in this third base here won't change anything. That's a silent mutation. But are you ready? They don't affect us, you're right. Are you ready? I'm going to change something else. Okay? Let's pretend that by accident polymerase, whoops, added a nucleotide. Not supposed to do that. And because it added a nucleotide, everything got pushed down one. Here we go. Now let's see what happens. I want you guys to tell me what's going to happen now. Tell me what my sequence of mRNA is going to be now. If I added an A and pushed everything else down after it, what happens? What do I have to change here now? You're right, G doesn't go with G, it goes with C. So take a look. I have these guys up here, and I have to turn these guys to match these guys. These guys are still good. TAC and GGG stick to these guys, no problem. But since I changed these guys up top, I now have to change these guys down below. So what is that going to look like? AAA should go to what? I'll go over 5 in a bit, Ryan. Let's finish this first. UUU, correct. So let's change that to UUU. TCA, what should this be? GUG. TCA, what should this be? T to what, C to what, A to what? AGU, correct. AGU. Good job, Hannah. Okay. So this was our original protein. This is a protein that works. This is the one we want. But we just added a nucleotide, pushing all the other ones down. Now we've changed this. Let's plug these guys into our wheel and see how it changed our protein. So UUU, when you plug it in, what do you get? Start with this U, and we work our way outwards to the next U, and then we work our way outwards to the last U right there, and what do we get? Oh, I did. You're right. So this leucine is going to be different. There we go. U to U to U. gives us phenylalanine. So we'll just write PHE. Okay. Correct, Celine. I'll draw an example of that, right? Now AGU, A to G to U, gives us serine. And C-stop isn't a thing, so I don't even really have a stop codon anymore. It's all wrong, right? So if I change a base, if I substitute a nucleotide, that might not be a big deal, right? That might not be a big deal. But if I add a base that wasn't there before, it pushes everything else down, right? So when I added this A here, it pushed everything else down one. And look, it completely changed all the amino acids after that point, right? Big problems, big problems. Now here's why it's a big problem. Let's pretend I have my polypeptide chain. Here are my amino acids in a chain. We have 5 amino acids, right? That's how many? 1, 2, 3, 4, 5. This is met. This is pro. This is leucine. This is valine. And this is stop. Okay? So this is our normal protein. Now let's pretend leucine is positively charged and proline is negatively charged. What happens when a positive gets next to a negative? What do they like to do to each other, guys? Positive when it gets next to negative. Help me out. We're almost done. They attract. Good job. So it would look like this. You've got your M, your proline, and because these guys are positive and negative, they're going to get really close to each other. They're going to stick together, right? But let's pretend in our new protein here, metpro phenylalanine serine, right? This is this one right here. Met pro phenylalanine serine. Let's pretend that proline, well, we know proline is negative. Let's say that phenylalanine is also negative. What happens when negatives get next to each other? If you try to put 2 negatively charged magnets together, what will they do? They'll repel, right? So our normal protein should look like this, but these guys don't like each other. So they're actually going to try to get as far away from each other as they can on their little chains. So they might end up looking like this, which is going to change our shape. And if you guys remember about proteins, just like a tool in your workshop, a tool can do its job depending on its shape, right? A hammer can hammer in nails because of the shape of the hammer's head. If I change the shape of the hammer's head, it might not be able to hammer in nails anymore. If I change the shape of the hammer's head into a metal spike, I certainly can't use that to hammer nails in, right? If I change the shape of my protein, that protein might not be able to do its job anymore. And some proteins, well, all proteins, have a really important job to perform. Whether it's the protein in your blood, the hemoglobin that lets you get oxygen around the parts to your body, that's super important, right? Or it's the enzyme that helps you make energy, ATP synthase. If that enzyme were mutated, you couldn't make energy. You would certainly be dead, right? So changes in the DNA, more often than not, don't really do anything. But certain types, like if I add new bases, they can have huge impacts on an organism. Big deals, right? Okay, so in a nutshell, that's mutations. If you change the DNA, down the line, you will change the protein. Yeah, right? Like that picture I showed you of the woman with the mutation where she was growing fingernails out of her head because her hair follicles were making fingernails, right? So it's a big deal. Mutations often can do nothing, or sometimes they'll do really bad things, or very rarely they might do good things, right? A mutation could lead to a new trait that might make you better. Like maybe you're slightly darker colored, meaning you can camouflage better. You probably won't be able to shoot lasers out of your eyes or grow claws out of your fists, but it might make you just a little better at surviving than your friends. So there's mutations. They lead to evolution through the process of natural selection, which is what we're getting to at the end of this trimester. Okay. All right, any last questions on the study guide or otherwise that you guys wanted to go over? I would be happy to spend a few more minutes if you need it. Transcription happens in the nucleus, correct. Relationship between genes and protein. Soleil, we've kind of filled that out a few times now. That's what we were doing up here, right? That's the central dogma of biology. Your genes and your DNA code for your proteins. The recipe in a cookbook tells you how to make the meal, right? So genes to proteins, recipe to meal, right? Make sense? Okay. Number 5, sure. Is your number 5, is this one, your number 5, the same as mine? What are the 3 jobs, roles of DNA? Yep. Stores genes, stores genetic information, right? Yes, I'll do 6 as well. If you need to do number 5, guys, we already did that. You can watch the beginning part of this video on the classroom, which I will post after we're done with this review. So I'm not going to do the same question twice because that's wasting other people's time. So we'll move on to 6. What does the double helix model tell us about DNA? Hint, think about how DNA is held together and how the strands run. What do you guys think? Look at this picture, this double helix of DNA. What does this double helix, its shape, allow it to do very easily? I want to show you off. Yes, the shape, Hannah, allows it to replicate. That's what it tells us. It tells us how it coils up and replicates. Hey guys, this is Jean Ralphio. He's my best friend, aside from my wife. I thought I'd introduce him. He wants to go do stuff. Go on, go do stuff. Okay. Go over number 7 again. Oh, Lily, that took us 20 minutes to do. If you want, Lily, you can watch the beginning part of this video again, and I do all of this with everybody there. So Lily, we've already done this, and you can watch it, but I'm not going to do it again, okay? Cute dog. Okay, number 9. The difference between DNA and RNA. Soleil, you should be able to do that in your sleep. DNA and RNA. I know you know that. I'm not going to tell you what that is. You tell me what that is. Good job, Ryan. I'm proud of you, buddy. Number 12, describe the process of translation. Once again, I'm done filling in the answers for you. You're going to tell me what answers you have, and I'll tell you if you got it right. Nope, you do need to know 8. Oh, 8? No. No. You do not need to know 8. 8 is no. No more 8. There. Ryan, then you can come check in with me before the test. Or you can watch this video over again if you need to. But there's really nothing else I can give you right now. This is the best I can do at the moment. Okay. So, Soleil, the question was, where is that question? Listen to it. Describe process of transcription. Translation is to make a protein. Summarize the process of protein synthesis translation. That's what it does, right? It does make a protein. Yeah, if you guys want to stop by at the beginning of the school day, come and see me. I'm there at work at about 6:45. I promise you I'll be there before you get to school. Just walk into my room, and I'll be there to kind of answer any questions you might have if this wasn't enough for you guys tonight. Oh, Ryan, I didn't do too much. You guys are the best. I'm happy to do this for you. It's gratifying seeing you guys actually show up. I was worried nobody was going to show up. So as long as you guys are showing up, I'm happy to spend as much time doing this with you. All right. Is there anything else you guys want to know before I sign off for the night? Because I need to get my beauty sleep. Anything for you guys? 13? Okay. This thing right here, summarize the process of protein synthesis and translation. Oh, Snapsile, throwing some shade. Ouch. Okay. Ow, you get an F. 13 quickly. Is this one 13? Is my 13 the same as yours? Hello? Yes, okay. Vocab, I mean, you should have been copying down the vocab as we've been going along. There's been a lot of new words, and we say correct. Yes, okay. Summarize the process of protein synthesis and translation. That would be like asking, think back to our cook, our chef analogy. That'd be like asking you, describe the process of how a chef makes a meal. Ryan, you're not going to get an F. Ryan, you never get an F. I don't think you've ever gotten an F in this class. You guys are so bad at pumping yourselves up before tests. Seriously. So I'm going to ask you, Soleil, describe to me how a chef makes a meal. Remember our analogies. J'aime ne pas biologie. Well, you know, if your French is as good as your biology, then yeah, you're probably right. Well, you need to know the parts of a nucleotide. Absolutely. Ryan, biology is like learning a new language. You know, you might get A's and everything else. It's not surprising if biology is the one tough grade you have. Okay. You get ingredients. Those are the amino acids. So you know in translation, there's ingredients, amino acids that are needed. There are dudes who are bringing the ingredients to the chef. Who's the chef? What are the ingredients? What's the recipe the chef is reading? Who are the chefs bringing the ingredients to the ribosome? Or the chef, rather. Whoops. And what is the finished meal called? So, Ethan, what you described as transcription, right? That sous chef that copies the recipe, that's the mRNA. That is the transcription step. We're on the next step. Yeah, so the chef, who is our ribosome, good job, Soleil, gets the mRNA strand, and what does he do with it? Yep, so the ribosome chef gets his mRNA recipe, and what does he do with it in translation? Okay, so he takes a recipe and then he crumples it up, throws it in the pan, and makes a meal? There's more to it than that. Do you guys want me to draw out the analogy one more time for translation? I'd be happy to do it. Would that be helpful? Step by step? I'm going to do it anyways, because I think you guys need it. I'm doing it, Soleil, because I already did it once, and you're asking me the same question, which means it didn't stick, so I'm going to do it again. Here we go. Translation happens in the cytoplasm, right? So let's say this is our cytoplasm. Here's our chef, our head chef, right? We're doing translation now. There's his little hat. He's smiley, right? Okay. He is standing at his or her stove. There's the stove with the fume hood. There's the pot that's on the stove, right? There's some fire there. Okay. There's some stuff bubbling in this pot, right? Okay, great. Off to the side, there's a pantry, and in this pantry, there are ingredients like apples, we'll say, like chicken. There's a chicken with the drumsticks right there, right? There's our chicken with the drumsticks. Maybe there's a wedge of cheese, because you know how much I like cheese. Okay, good. So we have our chef. We have our kitchen, we have our ingredients, we have a sous chef here who's going to be bringing the ingredients to our head chef. There he is, right? He's bringing the ingredients to the head chef. He's got a platter and it's got an apple on it. Yay, ingredients, right? Look at that little apple. Huzzah! Okay. And we also have a recipe that was made in the secret room, and it has been thrown to the head chef, who is now reading it, right? This recipe was made in the nucleus, and it has made its way over to the head chef, right? Okay. I'm explaining translation, okay? This is translation, because the nucleus right here is where transcription happened. We're out of the nucleus now, so we're doing translation. Right? Translation. Okay. The one I was doing before, I imagine you're talking about transcription, Ethan, which happened in the nucleus. That's just copying the DNA into mRNA. That's this message right here, this recipe. This recipe was copied here in the nucleus. That was transcription. Okay? The chef, who by now, hopefully you know, is our ribosome. Okay. The chef, who is our ribosome, is going to read the mRNA recipe that was given to him. He's going to ask the sous chefs to bring ingredients to him so that he can make the meal. The sous chefs look like little T's with their crossed arms. They are tRNA molecules. tRNA. They are bringing the amino acids to the ribosome based upon what's in the mRNA strand. So the ribosome chef can combine the amino acids in the pot, making the protein. Okay. Ethan, translation is everything that happens after the ribosome gets the recipe. So it's not the act of getting the recipe, it's what does the chef do once it's in his hands. Ryan, if I ask you to describe it, if you want to draw a picture like this, that's fine, but you have to label everything and tell me what's going on. Transcription happens in the nucleus. Translation, the ribosome is what does translation, but the ribosomes are found in the cytoplasm. So you're not wrong, right? You're not wrong if you say it happens in a ribosome, but that's all happening in the cytoplasm. Hello, Nick. How are you? Nicholas. Okay. I'm going to show you the picture from the study guide now. We're going to actually put these guys side by side, and hopefully that will help a little bit. So let's minimize this, right? Come here, come on, there we go. Let's shrink you down. And then let's move you over here. Shrink you down. Okay, so let's compare the actual thing to what we drew. Number 3 is our ribosome, this big blocky thing, this whole area. This is the ribosome, that's our chef. So this is the kitchen, this is the stove, this is where the magic is happening, this ribosome right here, right? This is a sous chef. The sous chef, this little guy here, the tRNA, is bringing his amino acid, his ingredient, to the head chef, the ribosome. The tRNA sous chef drops off his ingredient. The chef combines ingredients, and this chain will slowly grow, one by another, right? Imagine this chain getting longer and longer, beads on beads on beads. Then it will fold up into a protein. So the chef combines the ingredients brought by the tRNA, the amino acids, to make a protein. The chef knows what to do by reading his recipe down here. This is the mRNA strand. The chef reads the mRNA. tRNA sous chefs bring the ingredients to the ribosome based upon what the chef reads in the mRNA. They drop off their amino acid. The chef ribosome combines them, and you end up with a protein. Okay? Sound good? That's all I got. I got to do dishes and go to sleep and drink some water because all this talking has made my mouth very dry. Trop beaucoup enfants en la course. Il y a trop des enfants en la cour. There are too many kids in the class. Is that what you're saying? Okay. All right. Are we good? My little soldiers, are you ready for this test tomorrow? Okay. Sounds good. Well, that's all I got. Thank you so much for coming. I'm going to post this to the Google. Ryan. Ryan says wait. Ryan, yes? Ryan, I will give you, I tell you what, Ryan, if you do the right thing, if you show up as soon as the bell rings, if not earlier, and you say, okay, Mr. Ahern, tell me everything. I have all these questions. I will chat with you for a few minutes before everybody else comes in and sits down and is ready to go. Okay? I can't take, it's already a short block, and this is a, it's a beefy test. It's been shortened to fit the block, but it's still beefy. So I can't take 10 minutes to talk to everybody first. So if you show up early, come straight to me instead of chatting with Willie and all those other distractions. I'll do the best I can to help you out before the test. And Willie as well. I will do that, yes, absolutely. Yeah, but Soleil, you didn't answer first. I think Ryan Burba answered first, didn't he? Pretty sure. Whatever. Okay, if there's nothing else, Ethan, you're period 3. That's the last block of the day. So you'll have plenty of time during the day to prepare. Look over your notes and whatnot. All right, sound good? You guys ready? Okay. I'm signing off. I'm going to post this video. I've also, folks, for those of you who are here, I've posted a bunch of animations and video clips to the classroom already. I highly recommend watching them. They are fantastic, and they are much better than my 2-year-old sketches that I did on a mouse today. So go check those out. Look them over once, twice, 3 times, however much it takes. You guys tomorrow start, it's a day 4. It's a 4 advisory. So it's going to be period 4, 5, advisory 1, 2, 3. Cool? All right. All right, I'm signing out. That's all I got. You guys are the best. Thank you for showing up.